Hi, I'm Tony Locker. I manage the product development team here at Littelfuse, and today we're going to talk about resistance grounding, our SE330, which is a resistor monitoring and ground fault relay in one package, as well as our standalone ground fault relay, the SE701. Now, when we talk about resistance grounding, we're talking about system grounding. Now, system grounding occurs at the source. So our demonstration here, these three windings here represent a generator or a transformer. So when you put in a system grounding, that's where it occurs. Resistance grounding, shown here on the board, is very simple. All it is a resistor, has two connection points. One, it goes to neutral, to the source. The second one, it goes to ground. That's it. This is actually pretty simple. There are two main reasons for using resistance grounding systems. One is if you have a ground fault in the system that's shown here on C phase of ground. In a different type of system grounding, solid grounded system, the ground fault current will be tens of thousands of amps. And that leads to the arcs and the sparks and the explosions that you always hear about, the arc flash hazards. But that doesn't happen with resistance grounded systems. The reason why is when the ground fault goes to ground, it's actually limited by the resistance. So it physically limits that ground fault current to a couple of amps. And IEEE says if you limit the ground fault current to 5 amps or less, there are no arc flash hazards. And some sources say up to 95% of electrical faults are ground faults. The second main reason why you want to use resistance grounding is because of continuous operation. Because your ground fault current is so low, it's only 2 or 3 or 5 amps, you don't need to shut anything down. Your processes can stay up and running, your feeders don't have to be tripped. But the last 10 or 15 years with the safety initiative, more and more people are using resistance grounding because of the reduction or elimination rather of arc flash hazards for the ground faults. So we're seeing it used in hospitals, data centers, typical manufacturing facilities. We're seeing a growth rate of about 15 to 20% year over year on resistance grounded systems. Now that's great and all, but it only really works if that resistor remains intact. Actually, the whole circuit remains intact. You may think, well, what could go wrong? Well, resistors do fail. Sometimes there's a loose connection, like I said, or there could be a stolen wire. It happens more and more in North America. We're seeing quite a bit. When that happens, the system transitions from a resistance ground system to an ungrounded system. And that brings a whole other set of safety issues, transient overvoltages, inability to find a ground fault along with it. So here I'll demonstrate. Now there's a preset time delay of 12 seconds with a mixture, there's no transients there for safety reasons. So after a period of time delay, if for some reason the circuit does become open circuit, our SE330 here will detect it and send a signal out to the plant personnel there. The other part of the SE330, I mentioned the ground fault earlier. I'll just demonstrate that here. You can quickly see if there's a ground fault, it detects it. Okay, so they know there's a ground fault on the system. The alarm that comes out and says, well, now I need to go find the ground fault. They can use what's called a pulsing system. So that actually alternates the current from a low value to a high value, cycles about 1 per second. The electrician then grabs his clamp on the ammeter and goes out and tracks down and finds the ground fault. For safety reasons, people are putting the SE701 in each of their feeders in the main switchgear. The main benefit of that is, the electrician says, yep, I know there's a ground fault, I acknowledge it, I see it. I'm going to look at all my 701s in my main switchgear to try to find out which one has a ground fault. The electrician starts out downstream of that to find the ground fault. So it expedites the troubleshooting process, but also there's a safety aspect to it. It keeps the maintenance guy out of the main switchgear. The arc flash hazards are the highest. We actually pioneered this technology about 25 years ago. We're the first ones to come up with this idea, and we really have taken a long way since then. So we had a customer of ours, a textile company down in the southeast. They had resistance grounding, but it's been in their place for about 30 plus years. And they were experiencing a lot of blown motors throughout the facility. They had no idea why. They tracked it down to an open NGR. They called us. They now have installed our 330 in all their systems. They told us we've saved a lot of motors by installing the 330 here.